Well, I think we have almost everyone. You can start whenever you want.
All right. Well, welcome everyone to this talk on variants. I'm Paul, and hoping to talk to you today about something that I think is a really underrated feature of Motoko, very powerful feature, and I think understanding it can help you understand just a lot about programming in general. A little bit about me. I used to work at Dfinity. I was writing Motoko in 2018, so a long time ago now. Looked a little bit different back then, and also worked on some of the things around Motoko, like the Motoko base package. Some things I wrote made it into there. Started working on a predecessor to what is now Motoko Playground, and I also wrote the first version of DFX, and was part of what became the SDK team. So still trying to stay active in the community and help people learn more about Motoko. And I just want to say thank you to the organizers for allowing me to speak today. And just thank you for attending. Well done for investing this time this week in doing this. And if you want to find me online, on Twitter, I'm at PY. I'm on GitHub at Paul Young, and most online things I'm using these handles, so you should be able to find me there. Well, let's look at some code. So this is Emacs, and I have Motoko language server set up. So this should be a little bit like what you would see on Motoko Playground, where I get some error information over here. And you can set this up too with your own editor. I think VS Code is probably the easiest way to get started. I also have this kind of debug statement at the bottom here, so we can actually run this file, and it will print the output down here. And if I tried to run it when I made a mistake, if I write it first, it will give me the same information that I'm getting from the error output, but it's not quite as helpful as being able to say jump to the next error and see it all in line. So I really recommend trying to get that working if you have time in your own editor. It's really helpful for quick feedback. Okay, so this talks about variants, but first I think we need some context about Motoko. And Motoko has structural typing. So that might not be what you're familiar with in other languages, which has or more of an emphasis on nominal typing. So what that means is we could write a class called foo and say that it has a value. And we'll just say that, actually, let's specify that it's in that. And then we can do semicolon. See, it's helpful. We could do the same thing, but give it a different name. And we're creating two classes that have exactly the same structure here. So in some languages, these would be two very separate, distinct things. So we wouldn't be able to do something like this. We wouldn't be able to declare a let binding over here and say that its type is foo, but we instantiate a class of bar. And this works completely fine. And we could do a similar thing. We could do it backwards, or the inverse. And we could say that bar is actually an instance of foo. And this all works completely fine because these two things have the same structure. And we can kind of tell that this breaks a little bit if we were to remove this value, because now it's telling us these two things don't have the same structure over here. One thing is just an empty record or object, and one expects to have a value. So That's useful context. And in case you didn't know, just quickly, the class keyword up here is really just syntactic sugar for declaring your own type like this, and then declaring a let binding, for example, that's just a function that returns that type. So that's kind of all is going on here. And by the way, Seb is going to be helping out in the chat. So if you have questions, maybe just put them there, and we can treat this a bit more like a pair programming thing, or feel free to jump in. So there we go. So if we were to say that this type also had a value, which was nat, this would complain now because it's missing that field. But then if that value is 0, then it's exactly the same. And in theory, I haven't tried this beforehand, but all these 3 things have the same structure now. So this should also work, which it does. So when you're saying class, you're really just saving yourself some typing of doing this, and it's a lot easier to use class if you want to think in those terms. But the important thing to take away from here is these are all based on structure and not on the name, and that's why we can do this type of thing. Okay, so on to sum and product types, which is maybe an unfamiliar term, but let's look at product types first. So product types basically mean this value and this other value and so on. So you might have encountered some of those already throughout this week, or just using Motoko. And a very simple one is a tuple. So we can create a tuple, and this is saying we've got 2 text values, A and B. We could also have a kind of sometimes more helpful version of this, or even represent tuples using records. And we just get the convenience of they have named fields and it's easier to follow. And these things are isomorphic, meaning we can switch between them. I guess we have to use equals. And no commas, semicolons. There we go. So these are very simple product types that are in Motoko. So some types are kind of the dual to that, where they're not saying this value and this value. They're saying this or that, or the next thing. So let's just take a look at what that looks like. And we can represent sometimes using variants in Motoko. So that could be, we have an A. Oh, this should actually be type, because it's a type. We could say we've got A or B. So this is representing this or instead of and. And we could even have some kind of argument here. So we could say, if you want to create this tag, you have to provide a nat. And we can even have what's called polymorphic variants, where provide some A here. And if you create an instance and you're using this D tag, you have to provide a value of whatever that A is. So let's look into some examples of that, some things that you might be more familiar with. So Booleans, pretty simple, true or false. We could create our own, we could implement it ourselves. We could call it Boolean so it doesn't conflict with the bool type in Motoko. And we could give it some tags in here. And I'm just going to put underscore at the end because I think there are some quirks with the parser around thinking that it conflicts with the built-in values. But this is our new variant, and it has two things it can be. It can be true or false. Really simple. So even if you have a programming language that doesn't have Booleans, which seems like the most, one of the most basic things you can have, as long as you have variants or some types, you could implement them yourself, just like that. But however, I would encourage people to not use Booleans as much as possible. There is this idea of Boolean blindness, which you'd probably go and look up after this. And the idea is you're passing around true or false, and you might easily get those things mixed up, or you might just forget what context they're in. And does true mean enabled, or does true mean disabled, or whatever? So you could easily represent a few different things that you normally use Boolean for, just using your own custom type. It's so easy to create. So let's think about what we could do. Say you had some kind of vote type. Maybe it's in the NNS. You could have accept or reject. And now it's just much clearer what's going on there. You're not thinking, well, did I get this backwards? It's pretty clear. And often, whenever I've used this approach, you might later feel like you actually need to expand on these options. In the beginning, it might seem really clear. There are only ever going to be two things. But what if later you realize, well, actually, I need to actually track when people abstain. Accept and reject is only when people actually vote, but some people may never vote. And this isn't such a big deal in languages like Motoko, where you've got true variants, but in some languages where you have algebraic data types, some types, things like enums in Rust and other languages, you can't always easily extend things this way, and maybe we can look into that later. Another example that that came up recently is I'd set something up in some code where I said, I want to enable this particular feature either before or after some event. And that was pretty good for a while. But then this other use case came along where actually I never want to enable it. And it was fairly simple just to extend this existing type to add this other field and move on. So yeah, I really encourage, try not to use bool. The built-in Motoko version of this is just bool. If you don't need to. It can be especially difficult if you're passing a bool in argument position to a function, or if you're just returning a bool, to get that mixed up, get it the wrong way around, and get into some trouble and basically have the opposite of what you want to happen at the wrong time. Okay, optional values are another thing that you've probably encountered so far. And there is built-in syntax for this in Motoko, but we can define our own. Some languages call this option, some languages call this maybe. So they might have different names for what we're looking at here. But in some languages, it's called some and none. So this means if you have some value, you're going to use this constructor. And if you don't, you just use none, and they're both of type optional. So anywhere that you can return a function, and typically in Motoko, you probably have done something like this. I forget which way around the question mark goes, whether it's before or after, because I use multiple languages that have this feature, but this is kind of the equivalent of, without the async part, of what you would do using the built-in Motoko type. But we just re-implemented it, and it's as easy as that. Some languages have this, it's called maybe, and they have just and nothing. So if you encounter that in any resources, it's the same idea. You either have a value or you don't. And instead of kind of passing null around and worrying about whether something is null, and perhaps not always having a type system help you with that, here, if we just try and pass a value and it's null, it's not going to work. You have to pass none, and the type checker will complain if you don't. So maybe we could very quickly try this. We're going to say it's going to be an optional of, and if I put null here, I can't do that. I can either put some nat here, or I can put none, and it's fine. But I can't just put a nat on its own, because we're missing this some tag in front of it. And we can't just put null or some value that we got as a function argument that got passed in that's very hard to track down. There's no way. And this is very helpful. And this is something I really appreciate about static types. And depending on where you are in your journey with languages with static types, you could feel a bit like they're just getting in the way, and they're really annoying, and you just want to get on and get your program working. But I would encourage people to think of the type checker as this other person almost who's trying to help you write your program, and that you can have a dialogue with it. And they're going to help you catch all these mistakes that you may make before you even have to run your program, so that when you put your program out there, you've got a lot of confidence about it. And users aren't going to run into certain problems like this and have the app crash on them or something like that. Okay, so another thing you may have run into or seen is results, or there's another type which is sort of isomorphic to that called either. And we can easily re-implement that ourselves too. It's at this time we have two type parameters or two type arguments. So I think in Motoko, they're called OK and error. And I think it's implemented exactly like this. And it's really as simple as that. And then you would have functions that just switch on one of these values. And if they get an OK, you can proceed. And if you get an error, you can stop. And that's how you can do interesting sequential operations where you're just going to short circuit essentially. Like if you're switching and you hit this error case, you're not going to continue. But if you get an OK, you can kind of unwrap it and continue and do something with that. And like I said, in some languages, this is called either, and these would just be called left or right. And the convention is they're actually flipped. So the left is sort of representing the error case or the failure case, and the right is by convention representing the success case, but they're really representing the same thing. Result is the one that you would you'd have in Motoko and that you can import from the base library. And what I like about result over optional is you can make this error argument text or a list of text. You can make it whatever you want, but you can say, well, let's just do this really quickly. You could say, when something succeeds, I want to have, let's see, what would be something more interesting? I don't know, one of the classes I created above, foo. But when it fails, I want to actually get an error message. I want to know what went wrong. And to construct that, you could say, I don't know, something went wrong is not a very helpful message here, but you can put useful information in here. So rather than you have this optional thing and you tried to construct something or you tried to do some operation and it failed, and all you know is that you got a none, or in Motoko, if you use the actual, like if you use the syntax, you would just get null. Here you can actually tag it with what actually went wrong. You don't just have to return null. You could return some useful error message to either yourself when you're debugging or users. And it can be really helpful. This could be even be a list of text in here, if that's even the syntax.
I have a question. I have a
sure.
question. Sorry to interrupt. I've seen some different patterns in the community around like this result. Would you recommend using a text for the error message, or I've also seen using a variance for the error message, like different variants, and maybe the final one like other, which is of that of type text. What would be like the best approach?
Yeah, maybe we could jump to that in the interest of time, because here I was really just going to show how you could re-implement tuples using variants, which is using records, and then lists using variants. Perhaps we could cover new types quickly, because I think that's really helpful. And then union types, this section here I was going to talk about, speaks exactly to what you're talking about, Seb. So
right,
if that's okay, I'll do that. I'll do new types quickly, and perhaps move on to this union types part, which is exactly what I was, what you just said. So just very quickly then, there's this concept of new types in various languages. Things like Haskell, ML languages have them. Rust has a patent for doing this too. And it's really another way to get the type system to stop you from making a mistake. And a very simple example of this came up recently. Was somebody was passing around a NAT, and they wanted to make sure that they were using the correct units for that NAT. And I think their exact case was kilometers or miles. But their problem is, if you're just passing around a NAT, you don't know what it is. And you might accidentally provide something in kilometers, which is actually meant to be in miles. And I think this actually happened. And I think there's a story about like the lunar lander crashing into the moon because some code to do with the trajectory and all the calculations was in kilometers and some was in miles, but I think they were just passing around some number representation that didn't let them distinguish between the units. So you can do something like, I don't know, distance, and say either kilometers nat or miles, but it's just as cheap to just say kilometers is this, and then you can never pass around just a raw nat, or you can never pass around miles where you expect kilometers. And if there is a function that accepts both, which you can represent up here, if there's a function that takes a distance instead of a miles, that's totally fine. You just got to switch on both cases and perhaps perform some explicit conversion. Another thing that maybe there aren't multiple versions of are, say, a file path or a URL. You might need to do something at some point, maybe not file path in Motoko specifically, but I guess in general. Or perhaps we'd make this URL just to make it more specific. Maybe when Motoko gets the ability to make HTTP requests from canisters, you want to make a HTTP request. You really don't want to accidentally pass another text field to something that's going to make a HTTP request. You don't want to give it a username or someone's address or something like that. So you can use this pattern, and every time you create one of these values, all you have to do is tag it, and now you can't just like accidentally pass in some variable that you got which represents someone's name. It has to be tagged with this, and obviously you could still make a mistake here, and you could still write someone's name in this text here, but it's just another sort of safety net, another guard you can put in place and give yourself. All right, onto this section about union types and what Seb was asking about representing errors. So I think given the time that's left, I'm going to show some code that I wrote previously. If I can editor to do what I want. So I put some previous code in this utils file on the right here. And it's based on some documentation that's on this website, which is a Dfinity documentation website. This is a Motoko-based library. This is the result module. And there's this function called chain, which is related to what I was saying about this like sequential operation that you might want to do. Like if you have a result and then you have another function which produces a result, it will handle the unwrapping. If it's an OK, it will pass it to the next function, and you won't have to do this big nested switch case multiple times. But anyway, it gives you this example that I've modified here. And actually, maybe I'll just bring it up very quickly. So here it is. Here's the example. It might be a little bit hard to read, but we have these functions. One checks if a number is larger than 10. One checks if a number is smaller than 10. They both return a result. So if it's OK, so X is the nat. If X is larger than 10, tag it with the OK constructor and return that value. If it's not larger than 10, return this error, which is pure text. It's kind of similar the other way around with the smaller than 10, smaller than 20, sorry. Check if it's smaller than 20. If it is, tag it as OK. If it's not, return this error, but it's still returning text. So this is kind of what I was doing before. And maybe I'll just switch these around so we can see both of them at the same time. So except what I've done over here on the left is I've said I'm not going to use text. I am going to use a variant for my errors over here. So I've defined this error not larger than error. And I could have called it not larger than 10, but this way it's more flexible. I can put any number in here and say, is it not larger than 50? I can do the same thing with the not smaller than. And each of these functions now, instead of returning text here, they return a very specific error type. But one of the great things about variants is you can define these things in isolation. So these could be, right now they're kind of operating in the same domain. They're both checking if numbers are a certain size. Maybe for organizational purposes, you'd want to put them in their own modules or something. So say we group these together just so we can visually have some separation, but let's say that all this larger than stuff was in its own module, but we still wanted to have the benefit of this very specific error type. And we had this smaller than stuff in a completely different module, but we still wanted to get the benefit of this error type. In some languages, if a language that has enums, for example, I don't believe you can do this in a nice way, because you need to define an enum that represents all of the possible errors and all of the cases. And we basically need to put all of these cases in one place like this and give it some name that made sense. And this is kind of getting into something called the expression problem, but I don't want to go into that now. You could look this up later for yourself. But what Motoko allows us to do, oh, actually, that I duplicated something here. Let me just get rid of this. What Motoko allows us to do is something called type intersections and type unions. So this might be somewhere here. I guess not. Maybe I lost it. But if you just search for union, and I'm not sure if this is the Motoko docs or not, but yeah. So let's just say type 1 or type 2. And there are some rules around the subtyping here, and they don't just work for variants, but they're very useful to use as variants. And what that means is we can now say, well, we have this new type called a between error. So we have this function between 10 and 20. And we want to combine these two previous error types that are variants and create a new type that is essentially the same as writing it out with a type with this case and this case. Or I guess technically it's this case or this case. So in this example, it's perhaps not as compelling, but you might imagine you have a function, and again, maybe not in Motoko because you can't really do anything with files, but it's pretty common to have operations like, I want to fetch some resource using HTTP request, and there's a whole group of HTTP errors that can occur. And then you might want to do some file operation, like write to a file or read an existing file, and then depending on what's in it, write back to a file using the result of your HTTP request. And suddenly you have these two incompatible error types that they don't compose, they don't go together. And it'd be really nice to just say, okay, well, I'm going to return a HTTP error or a file IO error. Or maybe in Motoko, it's more like a HTTP error and a parse error. Maybe you're getting this data, you're going to parse it, it might fail. The HTTP request might fail. And then you could write a function, and you can even do this in line, because you can have, I believe, anonymous variants, we're about to find out, where we just take what's here and do it completely in line. So you don't even have to name. You don't even have to name this new type. And I believe this will all still work. I bring back my my error information here. Yeah. So if I said that's wrong, I guess we're not seeing any error information anymore. Maybe it died. But I'm pretty sure this works. But it's just nice and convenient to declare this type alias up here. And I feel like that's a really nice feature that not a lot of languages have. And some languages have gone so far as to implement this functionality as a library because it's so useful. And we get it for free in Motoko. So it can be really helpful and useful. And again, this operation here, I'm just doing the same thing as the example, but I'm able to now put in return position this this new error that I created. And it would also work in argument position. You could create a function that maybe is print the error or convert the error to a string. You could have a function that takes a between error and returns text, and you would just case on it, and you would handle the not larger than case and the not smaller than case and return text from both, and that would work just the same. So I think that's pretty much it, unless we want to go back and cover some of the stuff that I skipped. But I'd love to open it up to questions if that's something people have. I guess, Sab, you tell me.
There is a question. Oh, smaller than 20 doesn't need a parameter in the function. I think it's line 15.
Line 15, let's see.
Sorry, line 21.
Okay, yeah, I have relative.
Wait. Okay, it's the last function, result.chain.
Oh, okay, this one?
Yeah.
Yeah, okay. I have relative line numbers because I find that useful. Sorry, that's confusing. So is the question, why does not smaller than 20 require an argument?
Why it has no parameter?
Yeah. Okay, so I guess there's two ways to answer this. One is that this is something called eta reduction, where there's basically there is a function here. Well, I can't use x because I already have something called x, where essentially this is what's going on. I don't know if the syntax is exactly right and if it's being checked anymore since I closed that other window, but this is essentially what's going on here. But because this is also a function that takes an argument, I just don't need to write it that way. But I guess the more interesting answer is when you're using this chain operation, it's what it's doing is it's calling larger than 10 with x, and it's going to return a result. So we can see here, larger than 10 returns a result. But smaller than 20, which is the next function, it doesn't take a result. So we can't normally call this function with a result. And what chain is doing behind the scenes is it's calling larger than 10, it's returning this result, and then it's doing the switch case for us. And if it's an okay, it's going to call smaller than 20 with the value. And that's fine because it takes that value, which is a net. If it's an error, it's not even going to call this. It's just going to return what's ultimately our between error. And it's going to do this short circuit. And you can, in some languages, there's specific notation for doing this, often called do notation. In Motoko, there's something similar just for optional types. So you can do something like, you can do something like this. This is actually a newer feature that I'm less familiar with, but you can say do, and then there's some functionality where you're basically performing operations that can return options. And if anything along the way fails, it will short circuit for you. And then at the end, I think you have to return some optional value. So it's kind of a similar operation, whereas here it's more like it's vertically aligned and it looks more like sequential code that way. Perhaps this is not a great example, but there's probably something we could look up here if this is to do with Motoko. Yeah, so this is exactly it. The option block where you say do, I think it's do question mark here. So you can do multiple things that return options without having to do a switch case along the way. And then at the end, as long as you return an option, you can kind of depend on, well, if this succeeded, I can use it down here. So maybe this, we could call this A. And then over here, you'd be able to do something with A, but this might also return an option. And then you might do something here with B, some function that gets called, function F and some function G. And you're not having to handle the optionality of it all. As long as at the end you do that, return an optional value, all the types will line up and it's very convenient. But I don't believe that works for result yet. So for result, you have to use chain. But that's essentially why this is happening here. And maybe that's more that you wanted to know. Maybe the first answer I gave is sufficient, but that's why. You don't always have to expand this and write func and give the argument a name to pass it on to another function. You can just reduce this to, there needs to be a function in this second argument. I think if we go back, yeah, so X, the first argument to chain is a value. The second argument to chain Y here, its type is a function. So as long as you provide a function here, everything's good. And smaller than 20 is a function that has this type signature. It matches. Does that answer the question? Or are there other questions?
I have a question. It's with the do block. I'm not sure I've understood everything. Like, what should be the type of, let's say, the last optional value we provide, the X.
Okay. Yeah. Okay. Well, let's just try it out. So let's say here we wanted to have an optional nat. And here we said, we're just going to hard code it right now. Actually, let me just make sure that this is all being type checked, because I'm not sure it is. Because that would be really useful to have on the screen right now. And yeah, it doesn't look like it is, because it's, okay, maybe we can do it a slightly different way. Okay, so at least I can get some feedback that way if this isn't gonna work. So let's see what's going on here. Expression of type nat on line 40 cannot produce type nat. Okay, that's a little confusing to me. Perhaps I am less familiar with options than I would like, because like I said, I prefer to use result. Let's go back to, where do we have that do? Okay, interesting, it's not there. There it is. All right, yeah, so I guess this is not great documentation here, and it's not particularly helping me understand what I'm supposed to do, but I have used this briefly and it did work. Okay, so perhaps what we need to do is this. Okay, so that succeeded now. Unfortunately, this over here is not working as I hoped. So that's less useful. But I think what we can do is something like, let's say we had another value here. So I'm just going to call it V. And this could be an optional net. And for the sake of this, we're just going to say that it's null. But maybe it's actually some function that returns an optional net. And we'll just check that this compiled. Yep. So then I think what we could do here is like V plus 42. Aha. So now we're back to this other error. But I think what we end up doing is something like this. Yeah, so the whole point is with this do block is that if anything failed, it would short circuit, but it would still return an optional. And I guess I'm doing a poor job of demonstrating this. Maybe we need to be force unwrapping the optional, which I don't even know how to do because I think that's a bad idea. But the general gist of this feature, as I understand it, and perhaps I can follow up after this talk with an example of how it's supposed to work, or maybe I can go and find an example on the Motoko test suite or something like that, is you're supposed to be able to do this type of thing where you could essentially perform a lot of operations that are going to return optional values and not have to worry so much about the optionality of it until the end. So it would be something along these lines conceptually, where maybe you're calling a function here that returns an optional net, and you're calling another function here that returns an optional net. And at the end, you can do something like this, where you don't, like plus doesn't know about optionals, but it will know about nets. And you could do something here where you can perform an operation as if you've unwrapped them all, but you've done it in kind of a safe way. And as long as you return an optional at the end, you can kind of have this convenience feature.
I was just checking, Matthew sent a link in the chat, and I think he used the exclamation mark, a bang sign, in the do block. So maybe that's like instead of having the exclamation mark x plus y plus 42, it would be x plus y plus 42 bang sign. I'm not sure.
Yeah, I'm not sure. It looks like he sent a link to a JavaScript one, or is that oh, he sent an earlier link. I see.
Yeah, this one.
Yeah, here he's ignoring the results, but I think he is trying to do the same thing. It's hard to tell because there are no types here, but I'm assuming what's happening here is account get is returning an optional. Oh yeah, so you put this bang here. Yeah, so maybe that is what we need to do, and this will look a bit odd because I'm doing like null with a bang, but you could imagine that's a return value of some function call. Okay, So this is saying what? Line 42. Okay, yeah, so it could be now I think we got it correct, but I'm doing this in the wrong module. So let me just switch back to the other one, this main module, where I can do this. Maybe we'll get type checking back, I'm not sure. Yeah, so here we can see I just made a trivial error. So yeah, this is exactly it. This is what I was trying to demonstrate, where you might have some function call here that that returns an optional nat. And then you have a different function call here that returns another optional nat. Within this do block, you can just do this bang. And if it's null, it will return, it will short circuit. If it's not null, it will continue to the next expression, I guess. And it will keep continuing as long as everything succeeds until the very end. So here you don't need to worry about switching on optional values.
Okay. And so if you have like X or Y, which is null, my option is also null.
Yeah, let's quickly do this.
And that's really great. Yeah, I've been in the switch case scenario where you have like 3 or 4 switch case. Really great to know that.
The downside is it only works for option, and in some languages it will work for other types. If you want to use result, you have to use chain, and it's conceptually the same thing. You're doing something, and then you're either failing early or you're continuing with the successful value. And okay, yeah, here. So it printed out null at the bottom, and then it printed out hello world. But here, if we were able to, I guess this is kind of cheating, but if we just said, this is now 1 and 2, it looks like it type checked. Now we get optional 45. So it's convenient, but it's limited to the option type only. It's not going to work for result, which I find more useful. It's not going to work for your own types. But if you're dealing with optional values, it's convenient.
Right, thank you. That's really useful, I think. We have just a last question. Someone is asking for a high-level view of like a quick sum up of what we've seen, if that's possible.
Sure. So I think probably the high-level view is you can think of variants a little bit like records, except here where we're saying, well, left and right. We could change this to a variant. Well, we already have something called my variant, but I'll just call it my V. This is now being changed into a variant. And because a variant's a type and not a value, we have to say text here, and we have to put this £sign here. And we have to put text here. So whereas before we had this record that said, we have left and right, or whatever fields you want to put in your record. And hopefully a lot of people are familiar with that. In JavaScript, they're called objects. They're everywhere. They're very convenient. They have named fields. The dual to that is a variant where you can have left or right or whatever fields you want to put in there and represent. And it's really a much richer representation of data. So even if you're passing around text, where is that example? here with the URL. You can go overboard for this. It can be overkill, but I guess I would challenge people to think, whenever you're passing around a text value or a nap value, do you really want any text or any nap value to be passed in there? What if somebody gets that mixed up? What if you're expecting a certain type of text value and it's really important to get that right, and you're in your own programming, you accidentally make a typo or put the wrong field name or something like that? It can happen. This kind of thing can really help you think about it, and it can help you model your program in ways through types that make it much clearer to the reader. So, for example, if I had some function and it didn't have a great name, I'll just call it F, and it had an argument that didn't have a great name, I'll call it X, and it took, I don't know, text and returned text, I might come back to my code and look at that and think, what does that function do again? Or I might be showing somebody else who's trying to help me debug something, and they really can't get anything from the types here. But if you're using types, and in particular, I think variants can help with this, and you had something like, well, I'm going to take a URL and I'm going to return, I don't know, a file path. It's much clearer what that function might be doing. Maybe it's making a HTTP request and writing to a file and then giving you the file path. You wouldn't actually know without looking, but you could gain some insight through the types of what the intention might be. And you can use other things like the function name to help, but variants can really help you, not make a HTTP request to a file path and then try and write to a URL. I don't even think you'd get very far with that, but you might be able to do that. You might write some code that all type checks otherwise if you just use text, and put a canister out there, and it's only when a user does a very specific thing, you hit that code path and suddenly the app crashes and you have no idea why. And especially if you're using this kind of thing with option, it might just fail. But if you were doing something like what we're doing here, where you can model your errors, and you can do them in isolation or in different places, and then you can compose them all, perhaps at the edge of your program, then you can gain much more insight into what went wrong, and that's always helpful.
All right, thanks a lot. That was really useful.
Yeah, you're welcome. Thank you.
Right, I think we can stop here, and we have the Dev Mentor session in 30 minutes. So see you there, guys.
Yeah, I'll try and be there. Thank you.
Thank you.